Hi, welcome. I'm trying to learn biology today, control of water balance, and after we've done it, we're going to do shoulder impingement training. And if you participate in the shoulder impingement training, that is at your own risk. And this is about internal anatomy and the blood system and urination. Okay, this is part 2 already, and now we're doing some questions. The first question is, how does the kidney control the water percentage? Okay, other question. No, that's not a question. Is it measured in percent of volume? The amount of water in the body has to be controlled. All over it. And this regulation of most of the regulation of water content is done by the kidneys. So overall, is it important to the amount of water in the body? And the kidneys are regulating the water content. Now, what is now water content? The amount of water, that is the water content. And the kidneys, they alter by regulating the water content. Now we're doing it also, additionally, controlling the volume and the concentration of the urine. Now the question is, what is the concentration of the urine? It is not written here, and I don't understand it. Now the question is, what is urine? It could be water, but it doesn't make sense. Okay, we're having an open question. You know, I said in the last part we need a new plan. The plan is we're having it centralized, we're having it brought out. The question is, what is urine? And it is not written here. So we can't really understand what the kidneys are doing because we don't know what is urine. Is urine water? The other substances? It's probably all together. We get something, but we don't need some broad understanding for that, you know. Okay, we cannot understand what the kidneys are doing because we don't know what urine is. Because we have to know what the kidneys are doing something with the blood. And at the end they're doing urine, but we don't know what urine is. So how should we understand what they're doing? And I don't think we are ever told now one question is, what are the kidneys doing? They're regulating the water content, but we're asking more practical. What are they mechanical doing? So, theoretically, regulating the water content. Now, what is the water content? And of what? Now, there could be 3 types of water content. The water content in the human body, in the human blood, the water content taken out, the water content taken back into the blood, and the water content inside of the urine, or in the bladder. And I don't think we get an answer to that. Now let's look mechanical. What is the kidney doing? Now the kidney in the next sentence is written controls the water balance. Here's written most of the regulation of water content is done by the kidneys. Now it's talking of the water balance. We understand it broadly. We are controlling the water balance. But now we are asking through what? They do this by filtering the blood. Now the question is, do we filter all blood? That would implicate that they filter all the blood which passes, but I don't think the kidneys can filter blood as fast as heart is pumping the blood. So yes, they filter all the blood, but not at the same speed as it passes through. These are important questions to find out how fast can the kidney filter, how fast do all these things then take and affect, which later on can happen. The kidney filters the blood to remove small molecules. The kidney takes out the molecules out of the blood. How does that happen? Does the blood pass through the kidneys? That is an interesting question. Are the kidneys at some place docked to the blood system and all the blood flows beside them? Then would be a good question. what is the name of the artery or vein or the blood vessel passing through it? That would be a very interesting question, and where I wonder, why did I never heard of it at all? Now, if the kidney is here, and the kidney is here, half underneath the ribcage, one's here, one is here, we have two. There must be then one blood vessel going in and out. Why did I never saw a picture of it? Okay, what are we doing? We're taking out the molecules. And when we're giving back the molecules and also some water and salts. I still don't believe that the kidney takes all the blood every time the heart pumps it through the whole body, and that happens pretty fast, and takes it out. So only does it give the water amount back which has taken out of the part which it had taken out of the blood system. I mean, look how the heart is pumping. The kidneys are not doing that the whole time. I don't know how long it takes. That would be another question. How long does the heart take at normal heartbeat to take the blood once through? I don't know it, but it can't be much more than 1 minute. Maybe the 2 or 3, but I don't think the kidneys can filter 5-6 liters of blood in 1 or 2 minutes. And take all the water out and put it back in. So we're taking a little amount of water out of that little thing that passes through. So we take the whole blood, we take a little probe, or what it's called. We'll take a little amount. Now, is it an efficient system? That is another question. If we're taking always a little bit just, how long does it take if we get the final little part of it? Now, if you have a pool or a puddle and you take always a liter out and put a liter back, at the beginning you will take almost all the time a new liter. But basically, you will just mathematically never reach the end and have everything once. There's this interesting, I think I had very recently heard about that again. With this thing, if you always come halfway towards your other hand, on both hands, you will never reach the other hand. Because you come halfway, and then halfway, then halfway, then halfway, then halfway, then halfway, then halfway, and at the end you're just 1 millimeter away, and you come halfway to the hand. You will technically never reach the hand. And basically you will take always something out. You will never have reached it all. And now the question is it an efficient way? Can it be that there's some tiny bit amount of blood which is never filtered? Can it lead to problems? Okay, and a certain amount of water and salts are taken back. So the kidneys are taking a little bit amount of blood out. Then we're taking all the water out of it. And when we're giving some water back with salt and glucose. What is all the waste? Comes into the bladder, as usually. The amount of water that is taken back into the blood is controlled by a hormone called antidiuretic hormone, which is released by the pituitary gland. Okay. The kidneys do not take all the time the same amount of water out. Like one could say a fixed number, take always 5% out. So that we are having always a little mixture in the new water. Now, we are told by the pituitary glands, by other hormones, it's all day sunny, we're in the desert, we haven't drunk in 2 days, we're not taking a bit of water out. All we're going to tell, we have drank so much, we are completely saturated, take as much water out as you can. And that is done by the diuretic hormone, which was released by the pituitary gland. Now the question is, where is the pituitary gland? But that's another question. Now, the pituitary gland can be disturbed, that makes sense, by drugs. And they're naming here alcohol and ecstasy. Now it would be actually interesting to have here other things listed apart of alcohol and ecstasy, which are probably things which might disturb the antidiuretic hormone output by younger people. And the more interesting question would it be probably for the kidney and overall health. What are the substances making problems by people we're more likely to have actual problems with the kidneys when we get older, and we're probably not taking ecstasy and probably also not alcohol. What I mean is the two examples here mentioned are for people who are reading that, but not for the people who actually need it that much. Not that I want to say that people should not know that alcohol and ecstasy have an influence on the proper functioning in the human body. Now, alcohol and ecstasy can disturb it. And the reasons they have opposing effect. That's also why we use it. Alcohol. Too much urine to be made by reducing ADH release, the antidiuretic hormone. I still can't decide how I pronounce that word. Antidiuretic, antidiuretic. I wanted to go for antidiuretic. I have no idea what the word means, but it sounds a bit like diarrhea, so antidiuretic, diuretic, but also antidiuretic is also not bad. Okay, in the next part we will continue, and we're going to look for alcohol and ecstasy, and we try to understand why reducing of that hormone causes too much to do. We want to understand basically just why that lower, that higher. Why do the kidneys work harder? No, basically we want to understand, so what does it mean to work harder with the kidneys? Does it mean to take more water out? No, the kidney is taking all the water out. It means not to take so much back, or to bring so much back. So if they're getting not enough antidiuretic hormone, we are working equally hard. We're working technically even harder. We're taking more water out. That's why we have to understand what is the kidney actually doing. Is it taking the water out or not? It is taking the water out. And now the problem comes that it doesn't take it properly back. Or is the problem that it does not take all the water out? There are certainly people who have problems with not taking enough water out. These are two problems, and we're already 2-3 steps in. A problem with the pituitary glands, a problem with releasing of too little of antidiuretic hormone, causes the kidney to make too much urine. That means to take too much water out and not to take enough back. These are 5-6 steps, and we want to understand every one of them, and at every one of them can something go wrong. We want to understand every one of them. But the new approach is, the new plan is to look into crystallize what is the point with getting stuck, crystallize at one point, do we have an answer here or not, and then we move it on. And we're remembering the question for later time to answer it later. Now, we're having 2 minutes for short impingement training. If you're here for biology, go directly to the next part. We will do no short impingement training. If you participate in the short impingement training, then it's better to ask what is that stand, and we're doing just a few shorter circuits. And now in front. Would be also interesting of if there are any normal types of foods which can improve the situation. Now, if alcohol is bad, an alcoholic drink, who knows what might be helpful. Next exercise. Back with shoulders. Up in front. But we have to understand what is even the desired thing. Do we have to have water out or air? We have to understand every one of these steps. And again, up and back, down, front, up, back, down. And now, long and stable arms. Go with shoulders down, back together, and turn the arms to the inside. And the arms to the outside, shoulders down, together. And the arms again to the inside, shoulders still down, together. Now the arms to the outside, shoulders down, together. Release. Now we don't have time, just a little stretching. Shoulders back and down. Pull the arm in, have flat fingers. Try to relax the arm, go back with the shoulder. And turn the palm of it up to the sky. Hopefully I got it. And we have arm. The shoulder is back and down. Pull the arm in, have flat fingers, try to relax the arm. Go it back with the shoulder, turn the palm up to the sky. No, we don't have time. So it was a very short shoulder pulling training or whatever. I thank you very much and next time.